Week 6, we start a new module, Module 4, Sampling. Chapter 12 addresses the sampling design and the stages in the selection of a sample. Sampling involves drawing conclusions about an entire population by taking measurements from only a portion of that population. The practical nature of research is clearly illustrated in sampling. Sampling is used because of the practical impossibility of measuring every population member. Seldom would a researcher have the time or budget to do so. Also, a researcher would rarely need to measure every unit, as a well-designed and executed sampling plan can yield results that may even be more accurate than an actual census. Samples also are needed in cases where measurement involves destruction of the measured unit. The first step in selecting a sample is to define the target population. Incorrect or vague definition of this population is likely to produce misleading results. The chapter contains an example list of questions that illustrate considerations needed in making a decision about the relevant population. Once the target population is defined, the second step is to select a sampling frame. A sampling frame is a list of elements or individual members of the overall population from which the sample is drawn. A sampling unit is a single element or group of elements subject to selection in the sample. Sometimes a list of actual population members exists and can serve as a sampling frame. More often, the researcher will need assistance of a director, panel, or mailing list in forming the sampling frame. Two sources of discrepancy between the sample results and the population parameters exist. Random sampling error arises from chance variations of the sample from the population. Random sampling error is a function of sample size and may be estimated using the central limit theorem. Systematic or non-sampling error comes from sources such as sampling frame error, mistakes in recording responses, or non-responses from persons who are not contacted or who refuse to participate. When researchers do not have an account list of population members, some type of systematic error becomes very likely. Internet surveys and consumer panels are very convenient, but make truly random selection difficult. Thus, when these methods are chosen, extra care needs to be taken to make sure that the sample has characteristics that indeed allow it to represent the target population. The next step is to determine if a probability or non-probability sampling method will be chosen. The two major classes of sampling methods are probability and non-probability techniques. Probability sampling is a sampling technique in which every member of the population has a non-zero probability of selection. Non-probability sampling is a sampling technique in which units of the sample are selected on the basis of personal judgment or convenience. The probability of any particular member of the population being chosen is unknown. Non-probability techniques include convenience sampling. This sampling procedure attempts to obtain a sample of convenient elements. Often respondents are selected because they happen to be in right place at the right time. Judgment sampling, also called purposive sampling, is a non-probability sampling technique. Researchers purposively or deliberately draws a sample which he/she thinks is representative. Thus, personnel biases of investigator have great chances. Quota sampling is a procedure that restricts the selection of the sample by controlling the number of respondents by one or more criterion. The restriction generally involves quotas regarding respondents' demographic characteristics, specific attitudes, or specific behaviors. Snowball sampling, where existing subjects recruit future subjects from among their acquaintances. These techniques are convenient to use, but more subject to systematic sampling error. Sorting out systematic sampling error from the random sampling error also proves problematic. Probability samplings are based on chance selection procedures. These include simple random sampling, systematic sampling, stratified sampling, and cluster sampling. Simple random sampling assures that each element in the population will have an equal chance of being included in the sample. In systematic sampling procedure, an initial starting point is selected by a random process. Then, every nth number on the list is selected. In stratified sampling, researchers divide the entire population into different subgroups or strata. Those subgroups are homogeneous. A sample is drawn using simple random sampling within each homogeneous stratum. In cluster sampling, the population is divided into n groups. Those groups are heterogeneous, called clusters. The researchers randomly select n clusters to include in the sample. With these techniques, random sampling error can be accurately predicted. The process for selecting sample units from a population is described in this chapter. A true probability sample can be costly both in terms of money and time. A researcher who must determine the most appropriate sampling design for a specific project will identify a number of sampling criteria and evaluate the relative importance of each criterion before selecting a design. The most common criteria concern accuracy requirements, available resources, time constraints, knowledge availability, and analytical requirements. Internet sampling represents some unique issues. Convenience samples drawn from website visitors or social networks are problematic with respect to generalizability. Drawing a probability sample from an established consumer panel whose members opt in can be effective.